Okay, so for the next one, we have the multiple integral. Okay, so we have here double integral and triple integral. So if you apply the double integral or the surface integral, for the triple integral, that will be also the volume integral. So note that you have to start evaluating from the core or from the inside. Take one integral at a time. So you have to do it one by one. And then note, if limits are constant and operation is multiplication division on the integrated, it can be solved by ES. Okay, so I'll be given an example of that later on, so you can really appreciate this note. So let's try to solve this one. For number one, we have the integral of x squared plus y squared. So we have dy dx. Okay, so we have here two integral. So this will be double integral. So double integral, since the first one is dy, we have to first write the limits of y. So the limits of y are 0 to x, okay, 0 to x, and then for the limits of x will be 0 to 1. Okay, 0 to 1. Okay. So let's evaluate this one. Remember, when we are evaluating dy, therefore you can treat the variable x as a constant. Okay. So this will be integral of 0 to 1. Okay. So evaluating that, you'll have, we are evaluating with respect to y, right? Therefore x is constant. So you'll have your x squared y plus y cube over 3. Okay, this is the limits of this one is from 0 to x. Okay, and then 1 0, and then let's try to substitute the value of limits. So the upper limit first. So x squared times x plus x cube over 3. Okay, so this is the upper limit, and then as you can see, the lower limit is 0, so it will just be 0 if you will substitute the values of 0. Okay, and then let's simplify this one again. So you'll have your integral of 0 to 1, and then as you can see, that will be x cube, right? X cube plus x cube over 3. So simplifying that, you'll just have 4/3 x cube, okay, dx. Okay, I forgot the dx here. It's fine. Okay, so let's integral this one. So performing the integral, you'll have here 4x raised to 4 will be now x raised to 4 over 3 3 times 4. Okay, and then this limit is from 0 to 1, and then as you can see, you can cancel out 4, so you'll be left with x over 4 3, and then this is the limits of this is 0 to 1. So substituting the value of 1, so you'll have your 1 raised to 4 over 3 minus 0 raised to 4 over 3. And then the answer will just, of course, the second one will just be 0. Then the final answer is just 1/3. So all you have to remember when you are dealing with multiple integral, double or triple integral, all you have to do is just evaluate it from the core or from the innermost part. Okay, so and you have to do it one by one until you go to the outer part. Okay, so the answer will be 1/3. Let's do number 2. Okay, so for number 2, you'll have evaluate the integral of z. Okay, we can. So this is actually triple integral. Okay, so triple integral z r squared sine theta dz dr d theta. Okay, so since the first one is dz, okay, again you have to start from the innermost part or the core. So dz, we have to first write the limits of dz, which is 0 to 1. Okay, 0 to 1, and then r will be 0 to 1 also, and then for the last part, d theta is 0 to pi over 2. So 0 to pi over 2. Okay, so this is where the note from earlier will be useful. So as you can see, all of the limits are constants, right? if all the limits are constant and the operation of the function is multiplication, as you can see that z r squared sine theta, they are multiplied with each other, you can actually separate them. So what will happen here is you'll have three integral. Three integral. So the first one for the z, so this is z dz, and then for the second one we have r squared, right? R squared dd dr, and then for the last one is sine theta. Sine theta d theta. And then just write their limits. Limits for z is 0 to 1, limits for r is also 0 to 1, and then the limits for the theta is 0 to pi over 2. And then you can just use your calcu in evaluating these three, and then multiply them each, and then this is really easy. You'll just get the answer of 1 over 6. And you can try it on your calcu. And then of course you can also do the one that I did earlier. Number 1, you can just integral it one by one. Okay, so for the first one, integral z only, because the first one is dz, therefore r squared and sine theta are just constant, and then apply the limits, etc., etc. Okay, so as you can see, that will be quite that will take a lot of time, and the solution will be quite long. So this is already a shortcut, and it will make your life way easier. I think we can move on to the next topic.